So what is the integration means? Suppose this is the one curve is there. Okay. And that curve is bounded by the two line. Or suppose we are taking one rectangle. So this is a rectangle. So rectangle we divide into n equal parts. Okay. So n equal parts. So the n equal parts. This is the rectangle. So what is the area of the rectangle? That is L into B. Yes, no? So what is the length? This is the length. So how I calculate the length? So this is x1 and this is x2. Okay. And the difference. So dx equal to x1 minus x2. Okay. So next, what is the breadth? This is. So this is the y1 and this is the y2. Okay. And the dy equal to y1 minus y2 or y2 minus y1. Okay. So how we can calculate the length means, what is that area means? That is dx into dy. Okay, dx into dy. Okay. So we need to find the total length. Okay. What is the meaning? We need to find all the areas. So we divide that rectangle in n parts. One part is dx by dy. So what is the meaning of all the parts? Then we have to make that summation. So this is only one part area, that is dx dy. But we need the total part area, total rectangle, no? So we need to do what is that? Summation. So that is means summation. So we divide that n parts. N parts means that I equal to 1 to n. Okay. So we divide into n parts. No? So we need to find the n parts area. So n parts area means that summation. So summation is nothing to what is that? That is integration. So that is dx dy. So what is the curve that is this is f of x comma y. So this is integration of f of x comma y dx dy. So here that double is there, no? So that we are using that double integration. Okay, understood? So this is that part of the double integration. So how we can calculate the double integration means, so we are taking to the one rectangle. Okay. So that rectangle we divide into n equal parts. Okay. And we did it every part area we are calculated, that is dx into dy. So n parts that we can write the summation I equal 1 to n dx dy. So summation is nothing to that integration. So that is dx dy. So double integration means that is dx dy. No? So we are going to the integration of f of x comma y dx dy. Okay. So this is the part of the double integration. So now how we can calculate what are the problems in the examination they were asked means. So let's see. I will share the PDF. See, so this is the double integration and the some properties of the double integrations. So integration of k into f of x comma y dx dy. So that k will be right outside. And the double integration of so the double integration of f of x comma y plus or minus g of x comma y equal to the double integration of f of x comma y dx dy plus or minus double integration of g of x comma y dx dy. So this is the general things. Nothing to worry about this, but we need the problems. So in here the problems are that very important and it's compulsory in the examination. Okay. See, uh, so next here the one problem is there. Evaluate the double integration of y equal to 0 to 2 and integration of x equal 1 to 2. That is x square plus y square into dx dy. Okay. So remember one thing. So when you are doing with the integration with the x, and similarly, when you are doing the integration with respect to y, then x as a constant. So you should remember everything. Okay. Then y is become constant. So that y is become constant, no? Then x square integration is become what is that? X cube by 3 plus. And that y square integration is become what is that? X into y square. Okay. And now apply the limits. So what are the limits? 1 to 2. So that is become 8 by 3 plus y square. Okay. Minus. Again, we have to apply the limits 1. So when you are applying to the limits of 1 by 3 plus that x is become what is that here 2, no? So 2y square and this is become y square. So here's that printing, not, it's not clearly that PDF. Yeah. So this is, so 7 by 3 plus y square. So at this end 7 by 3 plus y square, we have to do the integration. So that is become 7 by 3 into y plus y cube by 3. Y square integration is y cube by 3. So that interval is 0 to 2. So when you apply to the 0 to 2, the first thing is 14 by 3 plus 8 by 3 minus 0. So this is also become 0 and that is next part is also become to 0. So that is become 22 by 3. 14 by 3 plus 8 by 3. So that is become 22 by 3. Okay, understood? So this problem is very important in the examination point of view. 14 by 3 plus 8 by 3, that is 20 by 3. So especially in the examination, the example problems are very important. Students, you should remember one thing. The example problems are very important. So that is that first problem just know. And here the one more problem is there, SKQ. The integration of x equal 1 to 2 and integration of y equal 0 to x square plus y square into dy dx. So this is also, it's very important and they are giving as a short answers, SAQ. But in the examination, we can expect it. So remember one thing. So when you are doing the integration with x, then y as a constant. And when you are doing the integration with y and x as a constant. Okay. So this is the concept is here. The long, we can expect it in the short answers. But see, this problem is there, no? What are the problem we are discussing right now? And this is very important. See, evaluate xy dx dy, where r is a positive coordinate of the circle. X square plus y square equal to a square. So to evaluate the given double integral, so first of all, circle. So this is the circle. So in this circle, so there is the first coordinate, second coordinate, third coordinate, and fourth coordinate. Okay. So first coordinate. So positive coordinates of the circle. So positive means x-axis positive and y-axis positive. That should be what is that here on. Why? Because this is plus plus and this is minus plus and minus minus and plus minus. Okay. So this is that one. So this is that. So, but we need the limits. That previous problem, they did not mention the limits, but we need to the limits. So how we can get the limits means it is parallel to, it is meet to x-axis means we have to substitute y equal to 0. So when the curve is meeting to the y-axis means we have to substitute x equal 0. See, they given that x square plus y square equal to a square. Yes, now. So how we can find it's meet the x-axis means, so we have to substitute y equal 0. Why? Because at x-axis, the y coordinate should be 0. So that is become what is that? X square equal to a square. So that is x equal to plus or minus a. But they mention what is that? It is a positive coordinate. So positive coordinate means that we can write x equal to a. So that is a comma 0. Okay. So in the same way, that when you are meeting to that y-axis, that is means we have to substitute x equal to 0. So similarly, when you are substituting that x equal to 0, so that is become y square equal to a square. So y equal to plus or minus a. Okay. So again, we are taking that 0 comma a. Okay. So this is a comma 0 and 0 comma a. But see here, observe here one thing. See y values. So this is the y values. So y values is changing from 0 to a. So that we are taking the y coordinates is y equal to 0 to a. So what is the x values means that x values are changing from x equal to 0 to under root of a square minus x square and that xy into dx dy. Okay. Now this is the one. So y equal to 0 to a and integration of x equal to 0 to under root of a square minus y square xy into dx dy. So first we are doing that integration with respect to x. So when you are doing with respect to x, so when you are doing that respect to x, so this x is become what is that x integration is become x square by 2 y. So that is 0 to under root of a square minus y square into dy and take y as a constant. Now you can substitute the x values. So that is under root of a square minus y square by 2 into y. Now if you are doing that multiplication, a square, y square, a square into y, actually they did direct step. So from here you can see that 1 by 2, 0 to a square y minus y cube by y cube into dy. So that is become a square y square by 2 minus y power of 4 by 4. So now you should apply the limit 0 to a. Then so this is the things. Okay. So after some after a substitution of 0 to 1, so after substituting the limits, so then we are getting that 1 by 8 into a power of 4. Okay. So due to some network issues, the previous last problem, 0 to 1 and 0 to 1, 2 square plus y square dx dy. Okay, na? So first we are doing the integration 0 to 1. So when we are doing the integration 0 to 1, y square into dy into dx. So, so write this x square also. So first integration that is become 0 to 1. So that is become x square y. And this is become y cube by 3. So the limits are 0 to 1 into dx. Now 0 to 1 x square plus 1 by 3 into dx. So that will become x cube by 3 plus x by 3 and apply the limits 0 to 1 by 3 plus 1 by 3 minus 0 and minus 0, that equal to 2 by 3. Okay. So this is the integration part, double integration part. Is it clear now? So that is the double integration and the single integration part. Okay, thank you.